Expand 3 over 1 plus 3x as a series in ascending powers of x, up to and including the term in x to the power 3, indicating the range of values of x for which the expansion is valid. So firstly, the 3 over 1 plus 3x, we need to express it in terms of a power. So this is going to be written as 3. I'm going to take what is in the denominator on top. So it becomes 1 plus 3x. That is going to be raised to the power negative 1 because it was in the denominator. So every time you have got an expansion, you have got a power that is a negative, or maybe you are the square root of something. Okay, when you write it, it will be x to the power half. In other words, if the power is not a positive integer, okay, like if it's not a positive integer, mostly you are going to use this same way that I'm showing. So if you want to go direct, like the direct method for expansion is when you have got like powers 1, 2, 3, 4, up to 7, like that. Okay, like the same way you use the binomial expansion, the direct one. But in a case like this one, it's going to be a special case. So the first thing that we are going to do is you need to know, okay, when you have got an expansion, the binomial theorem. Now the 3 I'm going to write just outside like that. When you are using the binomial theorem, first get a first number that you've written. Now whenever you've got a power, if it is not an integer like from 1 up to infinity, you have got maybe a fraction or a negative power. You need to make sure that you write your expansion in the form 1 plus something, okay, and then to that same power. Is that okay? You should always have a 1 here. Are we good? Every time you have an expansion that has got a negative power or a fraction power, always make sure that the first term is a 1. For example, if the function you are given is 2 plus 3x, now the power is negative 1, they're asking you to expand. First, always make sure that this is a 1. How can I make it a 1? I'm supposed to factorize out a 2, okay? So this is going to become 2, open brackets. What will remain here is what? A 1. And then plus, what remain here is what? If I factorize out a 2. Yes, 3 over 2x. Now I need to put this like this. And then the negative 1, I'll write it there. Okay. And then the negative 1 now distribute it. So it will be 2 to the power negative 1, open brackets 1 plus 3 over 2 x to the power negative 1. So 2 to the power negative 1, we know that is 1 over 2. So this will be 1 over 2. And then you have got 1 plus 3 over 2x to the power negative 1. Now you can expand it because you have made this as a 1. Is this okay? Please always make sure every time the power is a fraction or it is negative. Alright, so we can now go on. So the expansions according to the binomial theorem, you get a first term which is a 1, you raise it to the same power that you've been given, right? That's negative 1. And then plus, I'm now going to write this. You write the power here which is negative 1, and then here now you're going to write a 1, right? And then you write the first term which is 1. And then these two values you are able to see here, negative 1 and 1, is supposed to subtract them. So it will be raised to the power negative 1 minus 1. And then you write the second term which is a 3x. So whatever is down here, that becomes a power 1. And then plus you write it again. The power is negative 1. Now you're going to write a 2. Okay. You again write the first term according to the bracket, that is a 1. You subtract these two, negative 1 and 2. That would be negative 1 minus 2. And then again write the second term which is a 3x. Because whatever is here, that becomes a power 2. and then plus, write it again, negative 1, 3. So whatsoever is here, you get it, that's a 1. You need to subtract these two values, negative 1 minus 3. And then whatsoever is the second term, write it again, 3x. Now this one which is down here, that becomes the power, so power 3. We only want to end to the term which has got x power 3, so we are going to just end on this one. Is this okay? Is this okay? So this is the same as the 3. Now 1 to the power anything is always 1, so this will just be 1. Okay, plus we have got negative 1 combination 1. This one, which is a negative 1 combination 1. Negative 1 combination 1, if you have got n combination r, this means n factorial divided by n minus 1 factorial. I mean n minus r, the same r which is down there. And then you again write the r factorial. So in this case, you've got negative 1 combination 1. This is going to be negative 1 factorial divided by, you subtract negative 1 minus 1, that is going to be negative 2, okay? To be negative 2 factorial. And then also even which is in the denominator, that is a 1. You write it again, you put a factorial. I don't know if this is okay. Is this okay? All right. Now look at negative 1 factorial. What does negative 1 factorial mean? If you have got 5 factorial, means write 5 times the number below it, which is a 4, times the number below it, like that. Now if you look at negative 1 factorial, negative 1 factorial means negative 1 times the number. What is the number below negative 1? Like negative 1 minus 1. What do you get? Hmm. Negative 2. Okay, again negative 2 minus 1, negative 3. Negative 3 minus 1, negative 4. So continue multiplying by those numbers. Now you see that the numbers are not going to end. So since I've got a negative 2 down, I'll just end at negative 2 and put a factorial, okay? And then here also write negative 2 factorial. So see that this negative 2 factorial and this negative 2 factorial will cancel. What will just remain is a negative 1. So negative 1 combination 1 is negative 1. In other words, when you have got a 1 here, as long as you have got a 1 here, whatsoever is on top will become the answer. So that will be negative 1. And we know that 1 to the power anything is still 1. Okay, so that will just be 1. So this one will just multiply by the 3x which is here. So we'll do the same, simplifying these others that we have. The next one which we have is negative 1 combination 2. This one, which means negative 1 factorial divided by, you subtract negative 1 minus 2, that is a negative 3. You put a factorial, and then the same thing which is in the denominator, which is a 2, put a factor. Of course, that's not a denominator. What is down? The combination. Negative 1 factorial means negative 1 times negative 1 minus 1, negative 2 times negative 2 minus 1, negative 3. Since I've got also negative 3 down, I'll put just the factorial here. And then divided by negative 3 factorial, 2 factorial. So what you're going to see is that negative 3 factorial cancels with the negative 3 factorial. And what is the value for 2 factorial? What do you know? It's what? So it's a 2. So that 2 will cancel with this 2. But on top, remember you have got negative and negative. So that will give us a positive. So we're going to have a positive. Okay. What has just remained is a 1 because everything has cancelled out. So that will just be a positive. And you know that 1 to the power anything is still 1. Okay. So that will just be 1. And then 3x squared, that will be 9x squared. After you do that, the next thing, go to -1 combination 3 also in the same process. So for -1 combination 3, that will be -1 factorial divided by, in the denominator subtract -1 minus 3, that will be -4, put a factorial, and whatsoever that is in the denominator that is a 3, you write it down also. So -1 factorial means -1 times -2 times -3 times -4. So at -4, put a factorial since I've got also a -4 in the denominator. What is the value for 3 factorial? Yes, 3 factorial is 3 times 2 times 1, which is a 6. So -4 factorial cancel with the -4 factorial. And then -1 times -2, that's +2, times -3, that's -6. So this 6 will cancel with this 6. So the answer that will just remain is negative. Okay, so that will be -1. And then this one, 1 to the power anything is still 1. So all we have is a 3x to the power 3, which is the 3 to the power 3 is 27, and then x to the power 3. And then plus, this was supposed to continue going, so just put 3 dots like that to show that it continues to go like that. Are we okay up to here? And then from here, we will go on and simplify more. So this is going to give us 3, open brackets, 1, -1 times 3x, that is going to be -3x. And then 1 times 9x, that will be positive 9x squared. Then -1 times 27 to be negative 27 x to the power 3 plus, put just the 3 dots, meaning, so this is the expand to the term in x power 3. So just multiply by 3. Now if you know you make a mistake, you can just leave it here. If they remove 1 mark, they can remove 1 mark for leaving it there if they want, but you can just go on and multiply. Obviously that's not something that is so cumbersome to do. Okay, what is the 3 multiplied by, so we have got 3 multiplied by 1, it is 3, 3 multiplied by 3, 3 multiplied by 9, okay, and then 3 multiplied by 27, 81, x to the power 3 plus, put 3 dots. So we have done the expansion. Now remember the question was also saying find the indicating the range of values for which the function or the expansion is valid. And what's the expansion that we had? The expansion was the 3, open brackets, 1 minus 3x to the power -1. It was a minus, right? Okay, that's a plus. So to find the range of values for which the function is valid, you just get this term, the second term, this term which contains an x. 3x should always be greater than or equal to this number which is here. Okay, this constant which is here, which is a 1. Meaning that x actually is the absolute value of that number that has got an x. Should always be greater than or equal to 1. Not always 1, but that same constant that you are seeing, okay? I don't know if that is okay. So this will mean that you have got the absolute value. We can remove the 3 outside. So it means if it was -3x, like this, if it was like this, it will still be absolute value of -3x, okay? And by the time uh, this comes out of the absolute bars, it will be what? positive 3, but the x will still remain in the absolute bars. Like we don't know if x is positive or negative. Is that okay? Ac- Actually, this sign, just pardon me, it's not supposed to be greater than, but always less than. Okay, always less than, not greater than or equal to, but always less than. Yes, go on. Yes, yes. So you always get the absolute value of this term. It should always be less than 1, like always smaller than 1, right? The absolute value should always be smaller than 1. Yeah. And then, so 3 will come outside the absolute value, so we're going to have this. Divide both sides by 3, so we're going to have absolute value of x being less than 1 over 3. Okay? Absolute value of x, we know that it means positive or negative. So I can as well write this as a positive or negative x. The absolute bar goes, it will be less than 1 over 3. Meaning that if I multiply by negative, you are going to have x being less than 1 over 3. Okay? Or, let me write here, x being less than 1 over 3, or x, if I multiply by a negative, the sign will change, being greater than 1 over 3. So this, you mostly see it, we've written it as actually this is going to be negative because we have divided both sides by a negative. So we're going to say that it is negative 1 over 3 is greater than x, which is greater than 1 over 3. So we can as well write it in this way. But if you end at this point, it is just okay at this